How are you, my friends? This is Calculus 1 solved questions using precise definition of a limit epsilon delta. This is only to remind you that given epsilon around L, the limit of the function as x goes to a, then we have to find a delta positive number around a. So you can see lecture number 4 continued. Question number 1, given the limit of the function 1 over x as x goes to 5 is equal 1 over 5. Use epsilon delta definition to find delta positive given that epsilon 0.1. So from the given, we can conclude that the function is f of x 1 over x, the limit is 1 over 5, and a is equal to 5, epsilon 0.1. Let's use method number 2. There are 3 methods presented in the lecture 4 continued. This is method number 2. We're using inequality approach. So let's start with absolute value of f of x minus L less than epsilon. So in the absolute value 1 over x minus 1 over 5 less than 0.1, then we can use case number 2 from lecture number 26 in the algebra course. We can apply case number 2 here, 1 over x minus 1 over 5 between minus 1 over 10, which is 0.1, and less than 1 over 10, which is 0.1 also. So we can add 1 over 5 to each side. So we will have 1 over 10 here multiplied by 2 up and down, multiplied by 2 up and down. 1 over x is greater than 1 over 10, less than 3 over 10. Now let's use the reciprocal property of inequality. This rule number 7, I will show it to you in the next slide here. So when you invert the fractions here, you change the sign of the inequality. So 1 over 10 becomes 10, less than becomes greater than, 1 over x becomes x, less than becomes greater than, 3 over 10 becomes 10 over 3. So x is less than 10, x is greater than 10 over 3. So now we have a is equal to 5. So we can find delta 1 is 5 minus 10 over 3, which is 5 over 3. And delta 2 here is 10 minus 5, which is 5. So delta will be the minimum of delta 1 and delta 2, the minimum of 5 over 3 and 5. So we can choose delta to be 5 over 3. This is rule number 7 from lecture number 26 in the complete algebra course. This is used in question number 1. Taking the reciprocals, we have to reverse the sign of inequality. Question number 2 is a really nice question. Given the limit of the function 3 minus 5x over 7 as x goes to minus 14 is equal to 13. Use epsilon delta definition to find delta given that epsilon is greater than 0. So here epsilon is not given as a specific number, but it is a positive number. So we can say the limit here is 13, you can see that. And the function itself is 3 minus 5x over 7. A is minus 14 and epsilon is positive. So we can use method number 3 from lecture 4 continued. We say the absolute value of f of x minus L. So we write here 3 minus 5x over 7 minus 13 in the absolute value, all this less than epsilon. Simplify this, 3 minus 13 is minus 10. And we leave this minus 5x over 7. Now remember, the absolute value of y is the same as the absolute value of minus y. This is from algebra course, lecture number 4. So we can just take a minus here as a common factor inside the absolute value. So this is absolute value of this will be minus absolute value of that. So we can remove this minus because absolute value of minus 1 is 1. So what's left here is the absolute value of 5x over 7 plus 10 less than epsilon. Remember that, take a minus as a common factor and then use the absolute value of minus y is the same as absolute value of y. Now we need to take 5/7 as a common factor. Why? Because we need to get a similar inequality here like star. We need to get absolute value of x plus 14 less than some number. We call it delta. So let's continue here on the next slide. So we can take a common factor 5/7. So 5/7, we take it from here, see, and this one we multiply by 7/5 when we take 5/7 out. So 10 times 7/5, cancel here, the 5 is 2 times 7 is 14. So we have 5/7 outside in the absolute value, x plus 14 less than epsilon. Now multiply by the reciprocal here, multiply by 7/5 on both sides. This becomes 1. So we will have absolute value of x plus 14 less than epsilon times 7/5. Now simplify more, we will have absolute value of x plus 14 less than 7 epsilon over 5. Let's call this inequality E. Now please compare now inequalities E and star. We say here absolute value of x plus 14 less than 7 epsilon over 5. So we can choose delta to be 7 epsilon over 5. This is question number 3. Given the function f of x 2x minus 1, find a suitable value of delta such that 0 less than absolute value of x minus 3 less than delta. Then the absolute value of f of x minus 5 is less than 0.25. This is the epsilon here, 0.25, and the limit is 5. So this is the function f of x to x minus 1. The graph here is a straight line. We don't have to graph it. It's very clear. And the limit is L from here. A is equal to 3 and epsilon 0.25. So we can use method number 1 from lecture 4 continued. F of x1 is equal L minus epsilon. So we can just replace here 2x1 minus 1 from the function is equal 5 minus 0.25. So take minus 1 on the other side, becomes 2x1 is equal 6 minus 0.25. Just make it a fraction here, 1/4, and multiply by 4. So this 8x1 is equal 24 minus 1. So x1 you can find directly 23/8, which is 2.875. Do the same for the second x. We have f of x2 is equal L plus epsilon. 2x2 minus 1 is equal 5 plus 0.25. You do the same until you get x2, 25/8, which is 3.125. So we found x1 and x2 from the function. So this is x1 on the number line. We can find delta. First, we find delta 1 and delta 2. So this is A is equal to 3. So delta 1 will be 3 minus 23/8, which is 1/8. And delta 2 will be 25/8 minus 3, which is 1/8 also. So delta will be the minimum of these two values, which is the same. So we can choose delta to be 1/8. Question number 4, find an open interval about a equals to 3 such that the absolute value of square root of 2x minus 2 minus 2 is less than 1. We have seen a similar example in the lecture itself. So here epsilon is 1, and the limit here is this 2, L is equal to the function itself is square root of 2x minus 2. So we can start from the given here, we apply case number 2 in lecture number 26. So the absolute value of all this less than 1, it becomes between -1 and 1. Then we add 2 on each side. So 1 less than the square root of 2x minus 2 less than 3. We square all sides. So we get 1 less than 2x minus 2 less than 9. We add 2 to each side. 3 less than 2x less than 11. So x will be 3/2 and 11/2. So this is x1 and x2. So the 3 steps now, we find each delta, then we choose the smallest one, then we find the open interval around A. So delta 1 will be 3 minus 3 over 2, which is 3 over 2. And delta 2 will be 11 over 2 minus 3, which is 5 over 2. We choose delta as the minimum of these two values, which is 3 over 2. Then we find the open interval about 3, which is a minus delta, a plus delta. So it will be 3 minus 3 over 2, 3 plus 3 over 2. Just simplify the fractions, 3 over 2 to 9 over 2. This is a nice question, question number 5. We have a rational function. Given the rational function f of x, 3x minus 7 divided by x minus 2. Find a delta positive that corresponds to epsilon 1 over 3 for the limit of this function as x goes to 3 is equal to 2. So the limit is 2, a is equal to 3. Okay, so this is the function, and this is the limit, and this is epsilon 1 over 3. Let's use method number 1. Let's find x1 and x2. You know the story now. F of x1 is equal L minus epsilon. So we write 3x1 minus 7 over x1 minus 2 is equal 2 is the limit minus 1 over 3. So this becomes 5 over 3. Cross multiply now. 3 times 3x1, so that's 9x1 minus 21 is equal 5x1 minus 10. So x1 will be 11 over 4, which is 2.75. Now we do the same to find the second x, which is x2. F of x2 is equal L plus epsilon. We go slowly here, 2 plus 1/3. And then we cross multiply after we add these two fractions. 2 plus 1 over 3 becomes 7 over 3. Then we cross multiply. We get x2, 7 over 2, which is 3.5. So we have x1 and x2. We can, on the number line, write them here around a is equal to 3. So delta 1 will be 3 minus 1 over 3 minus 11 over 4, which is 1 over 4. And delta 2 is 7 over 2 minus 3, which is half. So delta, we can choose the minimum of delta 1, delta 2, and delta we can choose as 1 over 4. For more questions on epsilon delta, you can visit the playlist Calculus 1 lectures, lecture 4 continued for more examples. And for more questions on Calculus 1 in general, you can see Calculus 1 solved questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.